Hello, this is question 7 from the 2020 June set of exams from Cambridge International, and this is paper 1-1. In the description below you'll find a link to an image of this question, and I recommend you try the question first before looking at the solution. This question involves trigonometry. We're going to have to equate two equations, and first of all we're going to have to prove an identity. Now don't be confused by this here, by the way. It looks a little like an equals, but there's 3 lines. It's really not much different than an equals. Often when we equal two things, it's something like a line and a curve. Those lines, they aren't equal, but we often say they are. We say they're equal because they are equal at some points. We're solving an equation. We're finding these 2 points. And when we use something like this, a triple one, it's more like you have a curve and then you have another curve, and it's identical at every point. So it doesn't just hit each other once or twice, it's identical at every point. That's all we're doing, but you don't actually have to worry too much about that at this level. Just think of it like an equals. So how do we prove one side equals another? You really pick one side, whatever side you want, you pick one side and try and make it look like the other. Now I can't think of much to do with this side, so I'm going to go ahead and pick this left side here, and I'm going to add these together. They're just 2 fractions. We add them as normal. I'll pretend you don't remember though how to add fractions, and I'll do it a slow-ish way. On the left we have cos. I'm going to just give myself more room here. I'll write this again. Now I know most of you probably add fractions much quicker. Cross multiply. I don't like ever teaching cross multiply. I think it teaches bad habits. So to add fractions, I like to have the same thing on the bottom row. So I'll just cheat and I'll multiply this guy by sine 1 plus sine theta, and I'll multiply this by cosine theta, and there I have the same thing on the bottom row. But unfortunately, like I said, I cheated. I put this here. I better put one of them up here just to even out. That'll cancel. These 2 will cancel now, so I didn't really cheat at all. And again, I added in I put cosine theta here. I better put it up top row as well. Okay, so that's just where cross multiply comes from, by the way. So now we can go ahead and just add these together because they have the same bottom row. And so let's add the top row together. We'll multiply it out while we're doing it. Let's speed this up a bit. 1 times 1 is 1, and there's a sine theta. There's 2 sine thetas, 2 sine theta, and then we get a sine theta squared. This side we get a cosine theta squared, and they're both over the same bottom row. So we can just write the bottom row. 1 plus a sine. I should have multiplied this out while I was there. No harm. Let's just clean it up over here. Let's see, what can we do? Now here's the most important thing we do. Cosine and sine. Cosine squared plus sine squared is equal to 1. This is something we're given on a piece of paper. We're told this, but we're also shown why it is. If we get a unit circle, a circle of length 1, this is where sine and cosine comes from. So that's just Pythagoras' theorem. Sine squared plus cosine squared equals 1. That's how sine and cosine squared are defined. So this just equals, let's put a 1 there. Okay, so if we add this together, we get, we'll clean this up, we get the top row is 1 plus 1 is 2 plus 2, so let's take 2, no, let's just write it here, sine theta. On the bottom row, no, we'll actually leave it like this, it'll make it easier, I've just noticed. Plus sine theta. Top row we can change. We can take 2 out of both of them. 2 comes out of 2 once. 2 comes out of 2 sine theta, sine theta. And on the bottom row we have cosine 1 plus sine theta. The same thing. Top and bottom. We'll just cancel them, and we're left with the answer. 2 divided by cosine theta. That's one way to do it. I'm sure there's multiple ways. When we're dealing with trigonometry, there's often many paths to get to the same answer, and that's just because cosine and sine are defined on each other, so there's often many paths to get to it. But this one is perfectly fine. There's our full answer, 2 divided by cosine theta. Right, I'll go ahead and rub this out and we'll do part B. Okay, part B gives us that this is equal to this. Sorry, I didn't write it out because I don't want to run out of too much ink. It's a problem with trigonometry, it takes a lot to write. So it tells us that this big mess equals this, solve the equation. Now this is one of the cases where they're not equal, they just have answers, they match at certain points. Doesn't look anything like that though. So instead of doing this big mess, let's just use this, because we're told it's identical. So cosine, basically this is just as good as using this. So let's solve that. How do we do it? Lots of students get really tied up on themselves on this question. The one thing to notice is sine and cosine can go together. There's a few ways for them to go together, but the easiest, the most common and most easiest way to go together is the fact that tan theta is equal sine theta divided by cosine theta. That's the most common way for it to go together. That's because it's the slope. The rise over the run. The rise over the run. That's what the tangent is. So we can actually make this look like this. If I multiply both sides by sine, I get sine theta divided by cosine theta on the left. Divide both sides by 2, I get 3 over 2 on the right. Well, this is just tangent of theta is equal 3 over 2. And they asked us to solve this for between 0 and 2 pi. So the calculator will only give us one answer. So we need to actually have a little understanding of what this looks like. So let me draw a picture of tangent between 0 and 2 pi. Well, it comes up here like this, but I don't need to draw it over here because it's less than 0. So it comes up like that. This is 90 degrees here. This is pi over 2. And then it jumps all the way down. It's a strange function like that. Jumps all the way down and does that. This is pi here. This guy is, I guess, 3 pi over 2, or 270 degrees. And it does it once more. Let's see. And, well, it says doing this forever, in both directions. But this is where we run out of room. This is at 2 pi in this case. So really what this question is asking is, tan theta looks like this. 3 over 2 is a very simple function. It's just a number. So numbers just look like this. Remember, think of this as y equals tan theta. You draw it like that. Think of this as y equals 1.5. You draw that like this. So where do they agree? They agree here and here. Infinite other places as well, but they limited this to this area. So put this in on a calculator. Theta is equal, well sorry, let me say that first. Get the inverse tangent of both sides. Inverse tangent 3 over 2. So inverse tangent and tangent destroy each other. And we're left with this on this side. Put that into a calculator and you will get, let's see, we will get 0.983. That's the 3 significant figures. But that's not our only answer. This answer here is not our only answer. This is in radians, remember. They gave us the question in radians, in pies. We give them our answer in radians. So this is one answer, not the only one. Here's another answer. Now luckily we understand this function quite well. How far is between these two? 180 degrees or pi degrees. So the other answer is pi plus 0.983. I think you can leave your answer like that, but I guess, yeah, what does it say? It doesn't say anything. This, I'd be perfectly happy accepting this answer. Or another way to write that, just put it in a calculator. You'll get 4.12. Well, the 3 significant figures again, we'll round it off there. That's what I've done anyway. So that's it. That answers both those questions. If you have any follow-up questions for me, leave them in the comments below and I'll do my best to get back to you. Thanks for watching and have a great day.